Hi there, guys. Now we're back to do another demonstration. Today I'll be going through external tangents. I'm just recap what a tangent is for those that are just joining. In geometry, the tangent line to a plane curve at a given point is a straight line that just touches the curve at that point. So I'll take out my reel of tape and I will demonstrate this. So here we have a circle. So anytime we get any line just touching this circle, it will be considered a tangent. So once the line comes across here. Alright, so I'll just use this to demonstrate. So right now my t-square is tangent to this circle at this point here. This is where interaction occurs. Straight line meets circle. So we are going to be working with that concept, and we are going to be creating an external tangent between two circles. Okay? So let me just read the question here. My two circles are going to be diameter 70 for circle A and diameter 30 for circle B, with a distance of 120 between. So let me just create my line. And that line is where I'll place my circles. So when we say diameter 70 for circle A, what we really mean is radius 35. How did I arrive at that? The diameter is always 2 radii. So 35 multiplied by 2. Radius multiplied by 2 equals diameter. Diameter divided by 2 equals radius. So let's go. My compass shifted there just now. Okay. So nice circle here. Circle A. Let me just put that in. And that is circle A, right? And the distance, like I said, is 120, which we just need to mark off 12 centimeters on our set square. Circle B is 30 millimeters diameter. So if that's 30 millimeters diameter, that is radius 15. Divide 30 by 2 to get radius. So that's it here. Nice. So that's circle B. A and B. Now what we're trying to do now is we're trying to create an external line connecting circle A to circle B. Okay. So what's the formula? The formula is that we're going to minus these two circles. And you say minus, we're going to minus either the diameter or minus the radius. So let's set up our little table over here, our little working corner. So what we need, circle A, which is radius A, is 35 millimeters. Radius B is 15 millimeters. So I put B here, and I put A right there. So it's a radius A and radius B equals, so B is 15 millimeters. So let's subtract this and see what we're going to work with. And whatever we get out here is the radius for our construction circle. So I'll just put here construction circle. Alright. 5 take away 5, that's something like a 0. 1 from 3, that's something like 2. always able to prove back your calculations. If we add the radius b plus the number we just got, we should get 35. 5 plus 0 is 5, 2 plus 1, 3, that'd be 35 with radius r. So that means our calculation is correct. Our construction circle is going to be radius 20 millimeters. Alright, so open up 20, and we will place our construction circle within circle A. So I'm going to share the axis of circle A to create my construction circle of radius 20. This is my construction circle. I'll just place a note out here so that we know this is construction circle. Okay, so far so good. Now, what we need to do, the next step is we need to bisect the distance between A and B. To bisect the distance between 2 points, we always open up our compass to more than half, less than the full distance, and we create an arc above and we create an arc below. And we do the same thing at point B. The idea is we're trying to get these two arcs to interact to form an X. The idea is that we're trying to connect these two X's to form a line, and that line would be our division line. Okay, that looks good. And our division line, let's call that point M. Point M represents the middle point. At point M, we are going to stab our compass at point M and open it to point A and create a semicircle. Obviously, this semicircle should end directly at point B. Cool. So, the point that we are interested in is the semicircle interacting with the construction circle. So that's point, this is right here. So I'll just highlight that heavier. And let's call that point X. So that's the spot we're looking for. And what we're going to do is we are going to connect point B to point X. And there we go. Voila. And in doing that, we don't move the T-square, we don't move any instruments yet. We actually place a set square behind, because the next stage is we are going to track this line. Parallel track is the correct term. What does that mean? We're going to transfer the information, meaning the properties of this line, somewhere else. To do that, we set up a set square behind the first set square, and this becomes our permanent set square. So this never moves. This is the one that tracks and slides. So I set up my permanent, and I'm tracking XB, which is the line, over to where both circles come in to my focus here on this line on my set square. Now I can barely see the edge of both circles. So that tells me now that if I draw a line from one circle, it will go to the next on the outside. So this is where my tangent line would go, right here. And I'm going to draw it heavy so that we can see it at home. And that there is my external tangent. Right, so let me recap. To get this external tangent, what we had to do is we had to create the two circles. Circle A is diameter 70, circle B is diameter 30. Let me just put in the information, 70 diameter, and this one is 30 diameter, right? The distance between A and B, 120 millimeters. So once we have it set up, we take circle A and we minus circle B. So 35, 15 minus 35, we get 20. And at 20 millimeters is our construction circle, which is right here. And I'll just put the arrow indicating where the construction circle is so that you guys can see. That's our construction circle. Then the next step, we actually bisect AB. By bisecting, we mean we find the halfway point. Once we found our halfway point, we stab there with the compass and we create a semicircle. A semicircle which starts at A and finishes at B. The objective of this semicircle is to interact with the construction circle that we previously created. This gives us a point called X, and we draw a line from X to B. Now, the last stage, we actually parallel track the line XB over to the two circles. And if you have done this successfully, the parallel track, both circles, the line touching both circles should touch simultaneously. And that's how we know that this line here with these two circles are actually in tangent. And that tangent is called an external tangent. As we can see, the line is on the outside. So that's the last thing I'm going to do. I'm just going to label what we have just done. And I think this tutorial is about finished. This is the external tangent. And that's it. That's a wrap, guys.